And so what we want you to do is identify the two different main types of structures. One is called faulting. So hopefully you could see in this picture that there's some layers, some rock layers, but they've been broken. This little block diagram is trying to illustrate what's happening here, that this layer here that's the darker brown is this layer down here, and there's this line that breaks them, offsets them. And so what we define as a fault is a fracture or breakage where there has been movement. So we know there's been movement because these used to line up, because our story is that when rock layers get deposited, sedimentary rocks, they're laterally continuous, which means, right, they just like a line. So if they're broken, we know that there's been a fault and there's been movement across that fault line, we call, right? So that's our first type of structure, is faulting. But we can also fold the rocks, and that's what this picture is illustrating. So we want to look at both faults and folds. Okay, so this is a side view, right? So the surface is up here in cross section, right? So remember, cross section is like cutting through the cake and looking at the layers of the cake. And so we want to look at those two and be able to identify them. So when we look at faulting, so hopefully this picture is helpful. So what we're trying to do here is show you that there's a couple different ways that the rocks can break and move. So the two types that fall into this category called dip slip means that from the side view, right? So we have two views here. This is the cross section, the side, the layer cake. And then we have a map view where we would look at the surface of the earth only, like if you were looking down from an airplane. When you have a cross-sectional view, so this is the 3D diagram. These are the diagrams that you see in the homework. It tells you what view it is. This means that you're looking at the layer cake, right? Looking at this side here. And we call these dip-slip faults because there is this vertical motion where the layers come across and they're offset. The layer comes across and it's offset. When we see that, we know there's been a fault. An earthquake caused these rocks to break like this. And we have two names that we want to apply to this. One is called normal, a normal fault, and one is called a reverse fault. And how we determine which is we have to look at what we call the hanging wall block. Which way did it go? Now, how do I know which one of these blocks is called the hanging wall block? Well, the easiest way to do that, in these diagrams that I'm giving you in the homework, this is the fault line. These are layers that have been offset. And so what we're going to say is you take your pencil, your finger, whatever you need, and you put it on this slanted line like this, and you go vertical. The block that you end up in is called the hanging wall block. Okay? And so I want to know which way did this block move relative to this one. So in this first example, the story would be that these two lines were layers, we're going to call them, right? We're connected. How did this get here? Well, it went up. So the hanging wall block moved up. Our definition of that is a reverse fault. You can see it in this 3D diagram. Here's a layer. Here's a layer. They've been offset. Which one is the hanging wall block? You put your pencil, finger, whatever on the tilted line that we're calling the fault, and you go vertical. You end up in the hanging wall and you ask yourself, which way did it move? If it goes up, that's a reverse fault. Here, it went down. How do I know? Well, I put my finger, my pencil, whatever on my fault line and I go vertical. I'm in the hanging wall block. So, which way did that one go? It went down. So down is normal. And you can hopefully see that in this three-dimensional block over here. We have the hanging wall block. How do I know? Put my finger on the fault or my pencil, go straight up. I'm in the hanging wall. It went down. Down is normal. That's a normal fault. Over here, in the hanging wall block, up. That's not normal. We're going to call that a reverse. So there's two types of faulting when we look at a cross-sectional view. These are called dip-slip faults, And the thing we want to remember is that in order to get a normal fault, that's caused by tension. So this one here is a normal fault. And the reason that we get this type of fault is by tensional stress, tension, right? So that's this view here. Up here, this one with the reverse fault, we're going to say that that one is a reverse fault, and that's because of compression. So that's the stress associated with a reverse fault. So we have three types of stress. We have compression, we have tension, and the third one is called shear. Okay, so whenever you have a reverse fault like this, it's always compression. Whenever you have a normal fault like this, it's always tension. How do you know? You need a cross-section view. You need the side view in order to identify either a reverse or a normal. Okay, you can't be looking down on the surface of the earth because you can't see the layers. If I was looking down on the surface, I can't see any of these. So I can't tell if it went up or down. So it's important that you understand the view when I'm giving you these little annoying blocks I'm giving you for homework. Know the view. If it's cross-section, it's got to be one of those two. And then once you identify based on the movement of the hanging wall, you can then tell me what the stress is because they're always associated. Compression with reverse and tension with normal. Okay? The third type of fault is something called a strike slip. That one, we don't have up and down motion. We have side to side, a shearing motion. And so this last diagram is a strike slip fault. And it is because of shear stress. Oops, I can't spell, right? So that's from shear. All right, and so how do we identify that? Okay, I know this is a little weird because this one looks really similar to these. It has an angle here and something that's offset. But because it's a map view, I'm looking down on the surface of the earth here. This is showing horizontal motion. These two show vertical. Whenever you have a map view, you're not identifying hanging wall or anything. You're just understanding that when you're looking down on the surface of the earth and you see something that's been offset, sheared side to side, horizontally moving, it is always a strike slip fault. And shear is the tension associated with that. So in those first 6 diagrams for the homework, you're asked to identify of those 6 whether it's a reverse fault, a normal fault, or a strike slip fault. And you're supposed to put the associated stress. And here they are, right? Compression goes with reverse, tension goes with normal, and shear goes with strike slip. Okay? Know the view. The view is important. Cross section, it has to be one of these two. If it's a map view, it has to be one of these two. And don't be fooled by this angle. It can be either way. You know, this angle, I don't mean to go crazy. We could make it go this way, like this. So I could change the angle of the fault, like this. And now, what do we have here? So look, this is still a cross section, still a side view. I put my finger or my pencil on the fault and I move straight up. This is the hanging wall. What did the hanging wall do here? It went down. Now I've changed this to a normal fault because down, moving down the hanging wall is normal. So the angle, do this progression, right? Whenever you see this view, cross section, put your finger, pencil on this tilted line. Move straight up. This is the block, which we call the hanging wall, that I care about. Did it move up or down? Down is always normal. Up is always reverse. So don't you feel like every time that every fault, has to have this kind of angle view. It can have any angle. So just make sure you go through that progression. Figure out which way, which block, which side is the hanging wall, and then which way did it go, up or down. If it went up, it's a reverse fault. If it went down, it's a normal fault. So that's the faulting stuff, at least in the short version we have in this little thing. We can work on this during the week, of course, but maybe this will help you get started on the homework. The second part is actually what we call faulting, or I can't speak, sorry, folding. And so now we can take the rocks and bend them. And usually this is because they are buried deep in the earth, there's hot, and they have the ability to flex over geologic time instead of break or snap when they're near the surface and they're cold and brittle. So what we discussed in lecture is there's two main types of folds. Something called an anticline, which looks like this, and a syncline, which looks like this. Most of the stuff that we're introducing in this 101 class is that these folds are caused by compression. We squeeze the rocks and they bend up or down. And so for our purposes, the stress that's associated with almost all of the faults that you see in the homework are compression. But there's two different types. And the views matter, remember. We still care about the view. So over here, we're looking at the side view. That's a cross-section view. If it's bowed up, it looks like an A. We call that an anticline. If it's bowed down like this from a cross-sectional view, looks like a sink or a smile, we call that a syncline. So in cross-section, we're looking at this bowed up or bowed down shape. The tricky part with folds is that in map view, they tend to look like this diagram. So this would be a map view. So once again, your view matters. We want to make sure we understand what view you're seeing. And you can see at the surface, see how this blue is forming a line or a stripe? And that's what this is. These are the stripes of the layers intersecting the surface of the earth. But this striped pattern is common for a map view of an anticline or a syncline. So how do we know which one it is? Because they both have a striped pattern. So there's two ways we can figure out what we have here based on these stripes. One is the age. So you have to remember that when we stack layers, we always said that the old's on the bottom. This tan is oldest, then the green is younger, yellow's younger, and the brown is the youngest. When I look here, we have this green is on the bottom. It's the oldest. And then I have the tan, which is younger. And then I have this yellow. And then I have this brown and another tan, which is a different layer here. What this is saying is this tan, it used to be connected. The dark tan and the light tan used to bow up and connect. But it's been eroded away. And it exposes older rocks. Because see this yellow? It's older than this brown. And so old is in the middle. So if you're given ages, if I was to tell you that this middle layer is the oldest, and these out here are the youngest, because that's information I can give to you, right? Then this would be an anticline just based on age. Old in the middle because we erode the A shape and we expose old rocks in the middle. For a syncline, it's the opposite. If we look here, we can see this yellow is old. It gets younger with the tan, younger with the blue, and youngest with the green because youngest is on top. So with the same stripe pattern, if I was to tell you that the middle is the youngest, then we would say this must be a syncline. Okay, so in this scenario where we know the ages, you're given the ages. I think I'd use numbers to do that in the homework. Old in the middle is always an anticline. Young in the middle is always a syncline. So you can use ages to tell you what's going on there. So that's one way we can do it. The other is to use what's called a strike and dip. And this is kind of hard to explain when... let me do this here. Sorry about that. When you weren't in class and stuff like that, but we can see that these layers in both these folds, they're tilted. They're not straight and flat anymore. We have a symbol that looks like this thing here called a strike and dip symbol, and it is a symbol that tells you, the reader, that the layers are tilted. This long line here is what's called the strike direction, and this little short line that is perpendicular points in the direction that the layers are tilted into the earth. So you want to look for this symbol. If on my map view here, I gave you, we don't want to do that. I gave you symbols like this. Let me put that there, like that. What this is saying is that the beds, the layers, are tilted away from the center. So that little tiny line is pointing in the direction that the beds are tilted into the earth. And so just based on that symbol and this map pattern, we would say this must be an anticline because these symbols are telling me that the layers are tilted away. So how do we tell an anticline? It either has old rocks in the middle or the beds are tilted away, and we know that by these little symbols called strike and dip symbols. And so, of course, the opposite would be true for a syncline. So if we had a syncline, we would say, well, the beds must be tilted inward, right, toward the center. So the symbols for a syncline would look like this, where they point into the middle of the fold, right? And so they're pointing into the middle, and that symbol is telling you that. So this map pattern with this stripes and these symbols with the little line pointing to the middle tells you you have a syncline. So in the homework, you have some side views like this. Usually those are easier to ID because pretty much if it's bowed up like this from the side and it looks like an A, it's an anticline. If it's bowed down like this and looks like a smile or a sync, it's a syncline. When you have a map view, it's challenging. You have to understand age and the symbols, what they mean. So if you have old rocks in the middle, anticline. If you have young rocks in the middle, syncline. And the dip direction based on these would tell you whether you have an anticline or a syncline. So that's the basics of the folds. The last thing I'll mention to you is there's also something called domes or basins. Now these are basically, you can see in a side view from this image, they look like they're bowed up, like an anticline. So they're very similar to an anticline. They have old rocks in the middle. The difference is, in a map view, there's no stripes, because as they intersect the earth, they form this circular pattern. So when you're looking at the folds in the homework and you see a circular pattern like this, you should think that's got to be either a dome where it's bowed up or a basin where it's bowed down. How do I know which is which? Because from a side view, it's easier, but from a map view, it's kind of like our striped pattern. It can be either. But we know one way, age. If I told you that the oldest rocks were in the middle of this bullseye, it would have to be a dome. If I told you that the youngest rocks were in the middle, it would have to be a basin. And of course, just like the stripe pattern, we can tell you the way that the beds are tilted to help you ID. So if I bring over my strike and dip symbol and I say, look, the beds are tilted away from the center. Away from the center is going to tell me that this, we're going to do that, away, they're all away from the center, right? And so if I gave you something like this is showing that all the beds are tilted away, away, away. That's a dome. And so the symbols can tell you what you have, right? You have to know what the symbol is, of course, but remember, the short line is pointing in the direction that the beds are tilted into the earth. So this is a dome. And of course, we could argue that if we wanted to show you a basin, we would just show you that all of these symbols are pointed toward the center. If they're pointed toward the center, then this must be a basin. So, the anticlines, synclines, domes, and basins have similar ID techniques, right? you look at the map pattern. In this case, it's a bullseye. Bullseye means dome or basin. Which is which? Either use the age of the rocks if I give you that information, or use the strike and dip symbols to tell me which is which. And just like stripe pattern, if you are given the ages, use that to tell you what it is. If you're given the symbols, use that to tell you what it is. So that's the Reader's Digest version of how to identify the different faults and folds, right? Be aware of the view and then go through the techniques I just described here. So hopefully this is helpful. See if you can get through the homework using that. And then, of course, this coming week will help you with all the other stuff that you need to make up. All right. If you have more questions, you can always email me.